Have you ever watched a team pour months of work into fixing a problem only to see it pop right back up again? It's so frustrating, right? Well, today we're going to dive into a core idea from Six Sigma that helps you move from just guessing to actually knowing, using data to find solutions that stick for good.
I mean, we've all been there. A huge new initiative gets launched, a ton of money is spent, but a few months down the line, yep, the same old issues are back. So what is going on? Why do so many of these well-intentioned, expensive fixes just fall completely flat?
You know, the answer is often way simpler than we think. We're busy putting a bandage on a tree's trunk when the real problem is deep in the roots. We're treating a symptom, not the actual cause. And yeah, acting on your gut feeling seems fast, but without data, it's basically like trying to navigate in total darkness. You're probably going to end up miles off course.
So in this explainer, we're going to build what I like to call a data detective's toolkit. First up, we've got to learn to speak the language of data. Then we'll make sure our clues are actually trustworthy. After that, we'll go on the hunt for the real root cause, check out some tools to confirm our suspicions, and finally, put it all together to solve the case.
Okay, first things first. Before we can do any of the cool analysis, we have to get a handle on the basic nature of the information we're gathering. It all starts with knowing exactly what kind of data you're even looking at.
It might sound complicated, but really almost all data falls into one of two main buckets. Over here, we've got discrete data. These are things you can count or put into categories. Think yes, no, pass, fail, or maybe A, B, or C grades. On the other side, you have continuous data. This is anything you can measure on a sliding scale, like temperature, time, or weight. Getting this right is so important because the type of data you have literally dictates the kinds of tools you can use to analyze it.
So that's our first big takeaway. Before you do anything else with your information, just stop and ask yourself, am I counting things or am I measuring things? Is my data discrete or is it continuous? Answering that one simple question correctly sets the entire foundation for a successful investigation.
Okay, so you know what type of data you have. Great, but that is only half the battle. What if the numbers you're collecting are just wrong? This brings us to a really crucial step, making absolutely sure our data is telling the truth.
This is where something called a measurement system analysis, or MSA, comes into play. Just think about it for a second. If your thermometer is broken, you can't trust what it says about the temperature, right? It's exactly the same in business. MSA is just the process of checking your thermometers, whether that's a survey, a sensor, or a manual process, to make sure they're giving you accurate and consistent results. Because bad data always leads to bad decisions.
So the takeaway here is simple, but it is so important. Your whole analysis is only as good as the data you put into it. Before you dive into making charts and graphs, you have to verify your measurement system. If you don't, you're pretty much building your solution on a foundation of sand. All right, now we have data that we can actually trust. This is where the real detective work begins. It's time to stop looking at the surface-level symptoms and start digging to find out what's really causing our problem.
And the best tool for this job is called root cause analysis, or RCA. See, instead of just saying, oh, sales are down, RCA forces us to ask, okay, but why are sales down? And when we get an answer, we ask again, and why is that happening? We just keep asking why until we get to an answer where we can't ask why anymore. That final answer, that's our root cause.
But how do you keep all those whys organized so you don't miss something obvious? Well, one of the best tools for that is the fishbone diagram. You can see here, the head of the fish is the problem. In this case, the cakes are burning. Then each bone branching off the spine represents a major category of potential causes. It gives your whole brainstorming session a really powerful structure.
Let's think about our burnt cakes again. Under the people bone, you might ask, is there a new baker who wasn't trained right? Under equipment, maybe, is the oven's thermostat broken? For procedure, are the recipe instructions unclear about the baking time? By exploring ideas inside these categories, the team can look at every single possibility instead of just randomly guessing. So the biggest lesson here is to fight that urge to just jump to the first easy answer. You have to dig deeper than the obvious symptoms. A tool like the fishbone diagram isn't just a pretty chart. It's a structured way to channel your team's curiosity and make sure you leave no stone unturned in the hunt for the real root cause. So, your fishbone diagram is now filled with all these fantastic potential causes. But how do you know which one of those is the actual culprit? This is where we need to bring in some numbers to confirm our theories. This brings us to a powerful idea called hypothesis testing. Now, it sounds really academic, I know, but the core idea is pretty simple. We can't test every single cake that ever comes out of that oven, right? But we can take a small random sample of cakes and use statistics to make a really good, educated guess about all the cakes. It's all about using a little bit of data to make a confident conclusion about the whole big picture.
I love this analogy because it captures the mindset perfectly. Think of it like a court case. We start by assuming that our suspected cause is innocent, meaning it has no effect on the problem. This is called our null hypothesis. Then we gather data, which is our evidence. And only if the evidence is overwhelmingly strong can we reject the null and declare that our suspect is in fact guilty of causing the problem.
And a fantastic way to actually see this evidence is with a scatter plot. This chart just puts two variables on a graph to see if they're connected. In this example, you can see a clear pattern. As one variable goes up, the other one goes up too. That's a strong positive correlation. But, and this is so important, be careful. This shows a relationship, but it doesn't automatically prove that one thing causes the other. That's a critical distinction to remember. Okay, so let's recap this vital step. Your brainstorming gets you a list of suspects, but data is what turns you into a real detective. Using tools like hypothesis testing and scatter plots lets you move from saying, I think this is the problem, to I have hard evidence that this is the problem. Whew! We have covered a lot of ground. So let's wrap this all up into a simple, powerful toolkit you can start using to become a data detective in your own world.
Here it is, your 4-step data detective process. Step 1. Understand your data. Get clear on whether it's discrete or continuous. Step 2. Validate your measurement system. Can you actually trust the numbers? Step 3. Investigate the root cause using a structured tool like the fishbone diagram. And finally, Step 4. Confirm your theory with hard evidence using basic stats to prove your case.
And that's the real magic here. By following this path, you're not just taking a random shot in the dark anymore. You've officially moved from just guessing what the problem might be to building a logical, evidence-based roadmap to the real solution.
So I'll leave you with this to think about. What is that one nagging, persistent problem, maybe at work, maybe in your personal life, that you could finally get to the bottom of now that you have this data detective toolkit in your back pocket?